Hi guys, my name is Chris Jackson and I'll be going over my progress report 2, and the topic of my project is thermal fatigue analysis of a brake rotor in racing applications. And this actually came from my own personal interest. I started racing when I was about 9 or 10 years old in karting, and I raced in Ohio and did some different sanctioned bodies, and I competed in the World Karting Association as well, and even some of the sports car Club of America stuff. So this project fits me pretty well. Moving on to the project overview, the goal of my project is to analyze fatigue within a braking rotor as a result of thermal saturation. So if you guys look at any car or any kind of professional body of racing, you can understand that these cars experience extreme conditions, extreme temperatures, um, different kinds of heat transfer and everything that's involved in a topic such as this. And that's ultimately why I chose it. And if you look at karting or Formula SE in a smaller scale, it parallels pretty closely with these, and because they're both pretty extreme sports. So the dimensions and the material properties and everything, they're all based off real world scenarios and applications. And I chose this to try to relate it as closely as I can to my own personal experiences. Now I chose to include some of the different governing equations to better understand, you know, how I'm developing my inputs and my boundary conditions and everything within this simulation. So you can see here that I'm trying to maximize heat transfer. I'm looking at different convective and conductive states that the rotor experiences, and it's subject to these different variables. And like I said before, this will ultimately help me with my inputs as far as how I'm going to set up my simulation within ANSYS. Now looking at the different dimensions of the rotor, I just provided this as an overview. You're going to go ahead and see here in a second how I actually modeled it within SolidWorks. But if you guys choose to actually try to develop this rotor yourself, you can refer to this. So here's the start of me modeling the rotor in SolidWorks, and you want to make sure that the units are in millimeters. This is what I use to draw everything in. And we're going to create our sketch off of the front plane. This circle serves as the OD of the rotor, and this circle serves as the ID. And we're going to set that at 220 millimeters for the OD and 120, or excuse me, 140 as the ID. And once that sketch is complete, we're going to go ahead and we're going to extrude that from the front plane outward at 4.064 millimeters. And this serves as the body of the rotor itself that pretty much makes contact with the pads. And we're going to go ahead and now we're going to draw some of the tabs that the rotor actually uses to mount itself to the hub assembly. And our the OD of this circle is actually the ID of the body of the rotor itself, and then that secondary ID circle is actually going to serve so we can draw the profile of the tab out. So you can see here that you know the line is connected to these two intersecting points. And these are the outer profiles, and everything's in symmetry here. So we're going to go ahead and we're going to make this at 12.5 millimeters from this plane that you see here. And here I'm just making sure that, like I said before, same diameter of the ID of the body of the rotor itself, so that everything's as a whole. And this circle that you saw that I just drew within the sketch, this serves as where the bolt can actually slide through to mount to the hub. And actually, when I run my ANSYS simulation, I'm going to use this as my fixed point. And once the sketch is complete, here I went ahead and I trimmed all the entities that I didn't need, and you'll see, that I'll have a closed sketch of the tab itself. Like just before, once the sketch is complete, we're going to go ahead and extrude it, and it's set at the same thickness as well as the body of the rotor. So now that that's complete, we can go ahead and we can include one of the other features that I like to use. It's a fillet, and it's going to go ahead and round off some of these edges that you see here. That's pretty sharp. And we're selecting 4 of the edges. And once those are selected, we're going to set those at 2.54 millimeters. So now that we have one tab that's complete, we can go ahead and we can select both the feature and the extrusion, and we can create our circular pattern off of this edge that you saw me click. And that's at 360 degrees, and we're going to create 6 of them. And here you'll see that we have our part that is it's complete and it's ready to go. So moving on, within SolidWorks you can select different materials. And here's a materials property list that I came across. And I'm going to go ahead and import this into ANSYS as well for my simulation. And this is going to serve as my baseline. So you can see that we have different properties such as the elastic modulus, Poisson's ratio, tensile and yield strength, tangent modulus, thermal expansion coefficient, mass density, and hardening factor. And once I establish my baseline, I can go ahead and I can look at these different materials that could be a potential alternative as to what it can improve on the performance of the cart, and compare that under the same boundary conditions in the same analysis. So once I have everything selected as far as the material property and the geometry that's was just created, I want to go ahead and show you guys how I imported it into ANSYS, and it's pretty straightforward. Um, but here we're going to select our proper unit just like we did before, and we're going to set it as a steady state thermal system. And we can go ahead here and select right click geometry and import your file. And you want to make sure that it's an IGS file, .IGS, and that's to make sure that it can be properly imported into ANSYS. And once you double click model, the actual part itself should populate and show here. And if it doesn't appear, there is a tab like a lightning bolt that says generate next to it. If you click that, it should show, and here you can see that the part is successfully imported into ANSYS. So now looking from here on out, from the direction of the project, like I said before, I'm going to look at different alternatives as to what materials I can use to run in these simulations versus my baseline that I'm going to run. I'm going to apply the same boundary conditions and everything, and I'm going to look at different plots of deformation and stresses and strains and see what is the best fit for alleviating some of this thermal saturation that you'd see in like racing instances while maintaining that structural integrity. So if you guys have any questions at all about this, please feel free to reach out. But that's all I have for now, and I thank you guys for your time.